Hello and welcome to the Chapter 11 review for our test this week on surface area, volume, arc length measures, sector measures, converting to radians, density, a whole lot of topics. We have a lot going on in this section. So let's go ahead and get started. So for our first problem, the cylinder shown has a volume of 54 pi cubic centimeters. In a similar cylinder, the dimensions have been doubled. What is the ratio of the volume, smaller to larger? So you could actually find the volume of this cylinder, double the dimensions, find the volume of another cylinder, and compare. But say they don't give you dimensions, they just ask you what would happen. So the key here is that the dimensions are doubled. And since this is a three-dimensional figure, there are three sets of dimensions. So you would write the factor, the scale factor here, and how many of sets of dimensions are being doubled or tripled or quadrupled or whatever it is. Since three sets of dimensions are being doubled, 2 to the third power is 8. So the ratio is 1 to 8. Let's say we said that the dimensions were being tripled. 3 to the third would be 27. So if the dimensions were tripled, and this is a three-dimensional figure, then you would have the new volume being 27 times larger than the original volume. Okay, problem 2. You should be able to see that a pentagonal prism is cut by the plane shown. If the plane is parallel to the base of the pentagonal prism, the cross-section is a pentagon. It's kind of hard to tell what's going on up here, but basically anything cut parallel to its base, that cross-section is going to have the same shape as the base. A figure is a cylinder with a radius of 6 inches and a height of 10. On top of the cylinder is a hemisphere with a radius of 6 inches. Find the volume. So we have to find the volume of a cylinder and then a volume of a hemisphere. So to find the volume of the cylinder, we find the area of the base. This is a circle. So for area, we're using pi radius squared. So the radius squared is 36 times pi. Okay, radius squared times pi is going to be 36 pi. That's the area of the base times the height, which is 10 inches, gives the cylinder a volume of 360 pi. Now on top of the cylinder is a hemisphere. And the formula for volume of a sphere is 4/3 pi radius cubed. So I can find the volume of a sphere and then divide it by 2. Or instead of 4/3, half of 4/3 is 2/3, and I can use that to find the volume of just the hemisphere. I want my calculator tool here. So the radius cubed, we said the radius is 6. So 6 times 6 times 6 equals 216 times 2 divided by 3. So that's 144 pi for the volume of the hemisphere. 216 times 2 divided by 3. And then in terms of pi, so 144 pi. When I add those together, I get C 504 pi. For number 4, that cross section that's cut at the edge there, that makes a triangle. Number 5, the base, side, and side view of a three-dimensional figure is shown. What is most likely the three-dimensional figure? Well, since the base is a square, okay, If I had another square, then I would have a square prism, but the sides would also be rectangles. So it's not a square prism. If this is the base and this is the sides, most likely each of those triangles is going to sit along a base and meet at the top and going to make a square pyramid. Number 6, you are finding the area of a cross section of a sphere. It is important that they tell you that the sphere, that the cross section that you're taking passes through the center of the circle, because that way the radius of the sphere will also be the radius of this great circle. If you cut this plane closer to the end here, it would make a smaller cross section than the great circle, and you really don't know enough yet to be able to figure out what that radius is. They want to find the area of the cross section. It was going to be a circle. Normally we would use the formula area equals pi radius squared. But in this case, they want it in terms of d, and they're using a capital D for diameter. So I know that if I have the diameter, to get the radius, I can divide by 2. And that's another way to have the radius. So that's another way to write the radius symbol here. So pi times capital D divided by 2 squared. That means we have to take this fraction and square it. How you take a fraction and square it is you square the numerator and you square the denominator. So I have the pi in the front here. Diameter squared, and 2 squared is 4. Now sometimes people forget, wait, how do I multiply basically a whole number by a fraction? You can think of this also as a fraction over 1, as a fraction with a denominator of 1, and you multiply across. Pi times d squared is pi d squared. 1 times 4 is 4. Number 7, a plane cuts through a cone parallel to its base, which shape is formed by this intersection, as we said earlier. Any plane that cuts a three-dimensional shape parallel to its base, the cross section is going to be the same shape as its base. For number 9 and 10, I'm going to suggest that you use guess and check, meaning you put each of these in and you try it. So a wildlife organization wants to fence off an area of a beach. Length is X, width is Y. Normally to find a perimeter, you need 2 lengths and 2 widths. But in this case, one of your lengths you don't need to fence. So if I plug these in, you're going to have 1 length and 2 widths. 1 length plus 2 widths, so 50 plus 20 plus 20 is 90. If I have a length of 40 and a width of 25, length of 40 plus 25 is also 90. For the next one, length of 45 yards, so 45 is here, and this is 22 and 2/9, 22 and 2/9. That's going to be 22 plus 22 is 44, plus 45 is 89, and 4/9. Okay, so this one is going to be 55 yards plus 18 yards plus 18 yards. So my whole numbers are 91. That's already going to be larger than the others. And 2 11ths plus 2 11ths is 4 11ths. For number 9, I know they give you a function here, but I would do the same thing. This is X, this is Y. 46, so you have 1 length and 2 widths. So with number A, letter A, 132 feet of fencing. 50 plus 40 plus 40, one length, two widths is 130. One length is 63 plus a width of 32 plus a width of 32 is 127. And already 100 plus 20 is 140. So C is the least. Number 10, I told you not to do. So now this is the part you've all been waiting for. I know, the radians. So the first thing when you have any of these is you want to set up the measure of the central angle. So that's the central angle is pi over 10. And you want to put that over this total circle. Since the measure of the central angle is in terms of pi, that's radians. And there are 2 pi radians in a circle. If this were degrees like we did for homework, the degrees of the central angle would be here, and this would be 360. But it's radians. So the measure of the angle in radians over the total circle in radians. We want to find the area of the sector, the green part. That's the area of the part over the area of the whole. The entire circle would be pi radius squared. So if the radius is 20, 20 squared is 400 pi. So when I cross multiply 2 pi times the area equals, I'm multiplying, over here I'll show you what I'm doing here. I'm multiplying the fraction pi over 100 times 400 pi over 1. Because this is a whole number, so it's like multiplying it as a fraction with a denominator of 1. When I multiply across, I get 400 pi squared over 100. That's going to simplify to 4 pi squared. Because 400 divided by 100 is 4. 2 pi x. I want to get x by itself, so I'm going to change the color here to help you here. I'm going to divide all of this by 2 pi on the left-hand side to get rid of x, and 2 pi on the right-hand side. And actually, I just realized, maybe you caught it, I put 100, I think I saw 100 down here somewhere, but it was actually pi over 10. So you might have caught that. I made that mistake, so let me back this up a little bit. Two pi x equals 400 over 10. That means 2 pi x equals 400 divided by 10 is 40 pi squared. I'm going to divide both sides by 2 pi. 40 divided by 2 is 20. Pi squared divided by pi is just pi. And the answer is 20 pi. For number 12, intercepted arc has a central angle pi over 3. So again, the measure of the central angle, which is in radians, over 2 pi, because that's how many radians are in the entire circle. This is the part, this is the whole. In this one, they give me an intercepted arc has a length Arc length is a part of the entire circumference. So the total circumference of the circle would be 2 pi times the radius, which is what we want to find here. So part of the circumference, total circumference. Here I can simplify this, and I can divide out these pi's, and 6 divided by 2 is 3. So I end up here with 3 on the top and the radius on the bottom. So I've simplified 6 pi divided by 2 pi r. Now ignore that for a minute because I'm going to cross multiply here. 2 pi times 3 is 6 pi. Pi over 3, my pen is not working well, times radius over 1 is pi times the radius divided by 3. I now want to clear that fraction, meaning I'm going to multiply both sides by 3, and I'm going to get 18 pi equals pi times the radius. The pi's divide out on each side, and I get 18 is equal to r, the radius. Number 13. A circle has an area of 36 inches squared. What is the area of the sector of the circle that has a central angle of pi over 6? So once again, this is radians. Pi over 6 all over the total circle, which is 2 pi. We want to find, now we're doing area. The circle has an area of 36 inches. They've figured it all out for us. They want us to find just the area of the sector. So I'm going to cross multiply. 2 pi times x is 2 pi x. Pi, I'm going to do the work over here so you can see pi over 6 times 36, think of it as 36 over 1, is 36 pi divided by 6. 36 pi divided by 6 is 6 pi. Okay? So now I'm going to divide, change the color here. I want x, so I'm going to divide both sides by 2 pi. Six divided by 2 is 3. Pi divided by pi cancels out. And the answer to number 13 is 3. Not sure if I did number 14 or not yet. So I'm going to, actually no, I didn't. So for number 14, I actually think we did this one. Did we do 14 yesterday? Yeah. Well, we'll do it again because then I have to record it for the video. So for number 14, they want to find the area of a sector, but they talk about an arc length of 6 pi. So when we talk about an arc length, that means that the length is part of the entire circumference. So I'm going to put the 6 pi over the entire circumference. The formula for circumference is 2 pi r, and the radius is 18. So 18 times 2 is 36, times pi is going to be 36 pi. Okay?
Oh, so you just did the formula.
Okay, right. So I just did the formula. I'm now going to simplify that. And I'm going to divide the top and the bottom both by pi. And 6 over 36 simplifies to 1/6. So basically, I'm dealing with a circle. And the area, the length, of that circumference is 1/6 the total. That means that's going to create a sector that is 1/6 of the entire circle. So I have two choices. I can set it up like a ratio, and that's going to be the area of the sector, and this will be the total area, which I'm going to find in a minute. And I can use the proportion. I don't know, this is not writing well. It says total area. I know it doesn't look like it says total area. Or I can say, well, this is 1/6 of the total area. I can just find the total area and divide by 6. So to get the area, it's radius squared times pi, right? So 18 squared is 324. And what is 324 times 3.14? No, you're not done with the answer yet, so you need the total area. 1017. So if I cross multiply, I'm going to get 6x equals 1017.36, and then divide by 6. I believe in your calculator you're going to get 169.56, which is not the exact answer there. Because on USA Test Prep, they're using a pi button, and we're using 3.14. But still, when you get 169.56, given your answer choices there, you can get the correct answer, correct? On the EOC, they tell you to use 3.14. So that's why we're doing that. Are there questions on 14? Are there questions on 14? Talking behind me.
No, I'm explaining.
Okay. You have a question, or you guys are okay? Okay. For number 15, they're talking about a tent. Yes.
But you're putting that on the test prep?
What?
You're putting that on Teacher Web?
Yeah, I'm putting this actual paper on Teacher Web, and obviously the video that you're just asking me about what's on Teacher Web. We're recording. That'll be on there. Yeah. It's okay.
Right now?
Yeah, that's what I said. I said I was.
I caught myself, this is actually really cool. I taught myself how to do the recording thing, and then we had a project in yearbook where we had to explain how to use the yearbook system, and I did like a screen recording and a voiceover.
I want to see it.
It's 10 minutes long.
That's okay. I want to see it.
I can flash it.
Okay, not okay. Yeah, not this moment. I'm actually going to teach right now. But okay. So for this one, this image is not drawn out for you. You can kind of sketch something. I always tell kids when I do surface area, and I used to teach it in 7th grade. He said, first of all, make shapes of all of your faces to help you keep track of everything. A triangular prism is going to have 2 triangular bases and 3 rectangular sides. You're told that this front is an isosceles triangle with a base of 6 and a height of 4. So 6 times 4 is 24, divided by 2 is 12. So I have 2 triangular bases, each with an area of 12. Now I need 3 side lengths. And in this problem, I'm actually finding the depth of the triangular prism. Yes?
Can I say this right thing?
Yes.
The bottom one is 6. So one of them is 6.
Okay, so the bottom is 6, and it has a depth of what we're trying to find, which we're going to call x. So it is an area of 6x. Okay, but the other one is actually not given to you in the problem. They don't give you this. So you have to use Pythagorean Theorem. So if this is 6, if I make a triangle here, this is 3, this is 4. You may have caught on by now that 3, 4, 5 is a Pythagorean triple if you have legs that are 3 length and 4 length. The hypotenuse is 5. If not, you can use Pythagorean Theorem. 3 squared is 9, and 4 squared is 16, and 9 plus 16 is 25, and the square root of 25 is 5.
So you have, wait.
Yes.
So if you have 5 and 3, it's automatically 4?
If you're finding a leg, yes.
All right.
Yeah. So this is 5, this is x, this is 5x.
The other one's 5x.
5x. So this is just a strategy that I use where I draw out a picture of each shape. Now, they've told you that when you total this all up, you're going to get a surface area of 104. 12 plus 12 is 24. 6x plus 5x plus 5x is 16x. So when I subtract 24 from both sides, I get 16x equals 80. And then when I divide by 5, when I divide by 16, I get x is equal to 5. So you understand how to do that problem?
Yeah.
Okay?
The word depth.
Not drawing a scale.
What?
Not drawing a scale.
Wait.
Oh, okay.
Is there any way to prove if, like, can I go up to, like, show you?
Sure, go up to show me.
Is there any way to prove if this is going, like, down like that, or going,
That's crappy either way.
if this, see it, or, I have to, like,
Yeah.
but do you know what I mean? Like, going.
There's no way to prove anything. This is supposed to be a picture to help you understand what to do. So if you would draw a little picture, that's fine. It's a three-dimensional drawing. They always look weird because you're trying to make a 3D representation on a 2D space. I understand what you're saying.
Yeah.
But typically the symboling means the dotted lines are behind. Okay? Yeah, I'm going to just continue.
Yeah.
Oh, she saw it now. Okay. I'm going to continue on in the other classes. I've jumped and I've done later problems. Whatever we don't do today, we'll do tomorrow. So for number 16. Oh, what did I do there? That's not what I wanted. Actually, I lied. I'm going to stop because I've already recorded number 16. If a cut section of a cylindrical tree trunk is 20 feet long and 4 feet around, what is the volume of wood in the section of tree trunk in terms of pi? So basically, why is the slate not working? Why would anything actually work? Oh, slate's not working because it's so did. I know, and then this will be in the video, and it's so hysterical. I probably could, but that would take me longer to edit, so I probably won't. Okay. So, basically what we're saying is it's a very bad drawing, but we have a tree trunk. It is 20 feet long. 4 feet around means that's the circumference. I need to find the radius in order to be able to do this problem. So if the circumference would equal 2 times pi times the radius, and I'm told that the circumference here is 4, I divide both sides by 2, and I get 2 equals pi r. So for this problem, the radius is equivalent to 2 over pi. Since pi is a little bit more than 3, this is about 2/3 of a foot, but I want this in terms of pi. So I'm going to leave the pi symbol there. Now I'm going to find the volume of this tree trunk. In order to find the volume, I find the area of the base times the height. So to find the area of the base, the formula is pi
R squared.
radius squared. But I don't have it. What do I have for radius? I actually have the term 2 over pi. And that's squared. So 2 radius squared, but I already found that my radius is equal to the expression 2 over pi. So now I have to first deal with my exponent. So I have the original pi in the front here. 2 squared is, and pi squared is pi to the second power, or pi squared. I'm multiplying pi by this, which if that's confusing, I can think of pi over 1. Because when I multiply a whole number by a fraction, you can think of taking the whole number as a fraction over 1. So now when I multiply, I get 4 times pi is 4 pi. over pi squared. To simplify, I'm going to take a pi out of each of these. 4 pi divided by pi is just 4, and pi squared divided by pi is pi. So 4 pi is actually the area of the circular base. To recap what I did, I found that the radius was equivalent to 2 pi. I did 2 pi squared, gave me 4 over pi squared. I multiplied that by pi, I got 4 pi over pi squared, and I simplified that to 4 pi. That is the area of the circular base. In order to find the volume, I now have to multiply that by the height. The height is 20, which is the same as a fraction, 20 over 1. So then when I multiply across, 4 times 20 is 80. Pi times 1 is pi. And my answer is D, 80 over pi. I know that that's complicated. Really what we're checking there is your ability to solve a literal equation in algebra. You're putting in a different expression for one of the symbols and solve it. Okay? Are there questions on that one? Then I'm moving on to number 17. Yeah. What?
Considering that question took a really long time, how many questions are there on the test?
What do you mean how many questions are there on the test? However many questions there are on this review. I actually think there's only 19 questions on the test. I know, I think there's only 19.
And are any of them going to be like the same exact?
Nope, hope not. Yes. So, assuming the average composition of air weighs 0.0807 pounds per cubic foot, what is the weight of air in a giant spherical balloon with a diameter of 6 feet? So the first thing you have to do is you have to find how much volume is in the sphere. So the formula for the volume of a sphere is 4/3 pi radius cubed. When you put in, for the diameter is 6, the radius is 3, 3 cubed is 27. So basically, I know that's written there, but you have 4/3 times pi radius cubed is 27. So 4 times 27 is 108 divided by 3. That equals 36. And remember, there was a pi there. So your volume is 36 pi. Okay? Now, I'm going to get a calculator so you can see what I'm doing here. Oh my gosh, if I can get to it. They want to know the volume in pounds. The weight of the volume in pounds. So 36 times 3.14 means there are approximately 113.04 cubic feet of air in this balloon. And each of them weighs approximately 0.0807 pounds. And that's how you get 9.12. So it's approximately 9 pounds. Yes, I would prefer the answer say 9.1. Since 9.1 isn't there, because that's what it would round to, that's why you're going with 9.
Wait, so where did the 108 over 3 come from?
The volume. Here's the volume formula. So you first had to find the volume in the balloon. The balloon was 6 feet in diameter. So that's a radius of 3 feet. So first you had to find the cubic feet, the actual volume of the balloon. Then you figured out how much each cubic foot weighed. Are you sure? No. We'll come back to it tomorrow.
Okay.
Yeah, I can tell. Not sure. Like, okay, Ms. Falk, but okay. Use the fact that the length of an arc intercepted by an angle is proportional to the radius to find the area of the sector. Okay, we know how to do these. Forget about the fact here. We want to find the area of the sector. So pi over 3, this symbol means measure the central angle. And we've said this repeatedly. In radians, there's 2 pi radians in a circle. They want us to find the area. What do they want to find? Okay, so the whole thing about length of an arc intercepted, that's just to annoy me. They want to find the area of the sector. The area of the entire circle would be pi radius squared. 4 is the radius, squared is 16 times pi. So now I'm going to cross multiply. 2 pi x equals pi, I'm moving this over the side here, pi over 3 times 16 pi. That's 16 pi squared over 3, correct?
Yes.
So to clear that fraction, I'm going to multiply both sides by 3. I'm going to get 6 times pi times x equals 16 pi squared. I'm going to divide both sides by pi. And I'm going to get 6x equals 16 pi. I'm going to divide both sides by 6. And those are both going to simplify. They're both divisible by 2 to 8 over 3. The fact that they say this part about use the fact that the length of an arc interrupted by an angle is proportional doesn't help you. Now, there are other ways to do it. Okay? There are formulas and things that they do. This is not the way I teach it. If you want to read through this and find another way to do it, great. But this is how I teach it. Yes?
How do you know when you're supposed to use the radians?
Okay, she said, how do you know when you're supposed to use the radians? Since the measure of the central angle has a pi symbol in it, that's radians. Whenever they give you the measure of an angle with pi in the measure of the angle, that's radians. So they want you to be able to tell by looking at the symbol. I think every problem we have on here is radians. When we're finding measures of like lengths of arcs and sectors, I think all we have is radians. Okay, so we are doing problem 19 now. So this first part of the problem, use the fact that the length of an arc intercepted by an angle is proportional to the radius. We don't need this. We've been solving these all along. This symbol here means the central angle is pi radical 3. It's the central angle over the entire circle. The entire circle is 2 pi. Okay? They want us to find the area of the sector, and the radius is 2. So the area of the total circle would be the radius squared, which would be 4 times pi. Do you understand how I've set this up? Okay? 2 pi times x is 2 pi x. Okay? Now we have over to the side here, I'm going to say pi over 3 times 4 pi over 1, reminding you that when you're multiplying a fraction by a whole number, you can think of that whole number as a fraction over 1. So when I multiply that, I get 4 pi squared over 3. Okay? Now I'm going to multiply both sides by 3 to clear that fraction. I get 6 pi x equals 4 pi squared. Now I'm going to do this in 2 steps. I'm going to divide both sides by pi. So it's going to cancel out here, and pi squared divided by pi is going to leave me just a pi. So I have pi squared divided by pi. Here, if that would help, if I divide by pi on both sides. Does that help?
Yeah.
Change colors just to help keep track of it because I'm moving over here. So I end up with 6x on one side of the equation and 4 pi on the other. Because the pi canceled out here, and pi squared divided by pi left me still with 1 pi.
What's the point of not actually plugging in 3.14?
So that you get more comfortable dealing with pi as a symbol. That's really what we're practicing. First of all, this is all in radians. So in radians, you use the pi symbol, but also it's really practicing algebra skills to just help you say, okay, I can deal with a symbol rather than a number. So when I divide both sides by 6, that simplifies to 2 pi over 3. Also, I can simplify. If I had the 3.14 in there, it makes simplifying stuff way more difficult, right?
Yeah.
Okay, do you understand this one? Okay.
Wait, so that would be like an improper fraction, right?
Yeah, technically it'd be an improper because basically 2 times 3, right. In real life, if I estimated that pi is going to be about 3, 2 times 3 is about 6.
So it would be like
So a little bit more than 6 divided by 3, so it's going to be about 2. Number 20. We talked about this a little bit in problem 1. We talked about if dimensions are doubled. Here, you're talking about if the circumference of a circle is doubled. So when you're finding circumference, you're dealing with either the radius times 2 or the diameter, right? Either way, you're only dealing with one dimension, okay? So, but when you deal with area, you're dealing with how many dimensions?
one. No, 2.
Area, you're dealing with 2 dimensions. Even though it's, think of it this way, it's pi radius squared. That's radius times radius. That counts as 2 dimensions. So when you change the radius, even though you change one dimension, since then in the formula for area, you use that radius twice in squaring it, you're doubling something, and you have 2 dimensions. So 2 to the 2nd power is 4, and that's why the area is quadrupled. Okay? Do you understand number 20? Okay? 21. The circumference of the circular base of a cylinder is doubled. How does the volume of the cylinder change? So again, 2 is our factor. But in this case, if the circumference is doubled, it's doubling because the radius is doubling, right? But in this one, it doesn't say anything about the height. The height is not changing. So you still only have 2 dimensions being doubled. Basically, you have a cylinder, and the new cylinder has the same height. The circle, the dimension of the circle got doubled. So you're still only using an exponent of 2. Only 2 of the dimensions are getting doubled. So you still have that the volume is getting quadrupled. Do you understand 20 and 21? If you had to, could you make up a problem? Could you say, I don't remember the rule, and say, okay, I'm going to pretend I have a cylinder that has a radius of 2 and a height of 6 and double the 2 to 4 and see what happens? Yes, you can. The rule is you take the scale factor. So this is the big number, right? So in this case, they're being doubled. And 2 sets of dimensions that's happening to. If it was all 3, if it was volume and it was all 3 dimensions, then it would be 2 to the 3rd. And that would be, the volume would be 8 times larger.
What about if it was tripled, like the circumference was tripled?
Okay, so if the circumference was tripled, that would be 3. But if the height doesn't change, We still just changed the circle, but didn't change the height. That would be 3 to the second. So that would be 9 times larger. Okay?
Is there a name for stuff like that?
What?
Like
Dimensional analysis,
no,
I
like
think.
quadruple, like 8 times. You just say 8.
Yeah, you just say, 8 times larger. Yeah, it stops at 5. Quintupled, and then I think it stops.
They should make a word. Like
There probably is a word. If you look it up, there probably is. It's just not a word that we use.
Yeah.
We did that one year, like the students like looked up, and there's like the things we call like an 11 gon or a 13 gon or a 4. There's actually names for all of them.
Really?
Yeah. And I'm sure the students watching the video tonight at home and watching all of this are enjoying listening to this.
Oh, video. No. 6,000.
Proof that I teach, though.
Yeah.
That's good. I'm leaving it all. Okay. So 22 says you have a cone and a pyramid, and they're both 3 inches in height. But the cone has a radius of 4. And I know, isn't that great? And the square pyramid has a side length of 2 pi. Okay, so Noah, I don't know if I'm supposed to say names, but Noah, you're going to like this one because we're actually going to use pi because look at the answers. There's decimals there. Yeah, so we're going to find the volume of the cone. 4 squared is 16 times pi. Now, normally we would multiply by the height and divide by 3. But in this case, the height is 3. So if I have 16 pi, and I multiply by 3, and then I divide by 3, I'm back at 16. Right? So what is 16 times 3.14?
50.2.
Now, this has a square base of 2 pi. So 2 times 3.14 is 6.28. What is 6.28 times 6.28?
39.4384.
So basically 4, right? So if I were to multiply this by 3, because that's the height, and then divide by 3, I'm back where I started. So this cone has an area of 50.24 cubic inches, and this pyramid has a volume of 39.44 cubic inches.
Wait, do the pyramid again?
So 2 times pi is 6.28 squared. 6.28 times 6.28 is 39.44. Times 3, but then divided by 3. So you're back to 39.44. Okay? So when you subtract, you find the difference between the two is 10 points. We actually get 10.8. They get 10.79 because they used a pi button. Okay? But 10.8, and the cone is larger. That's why it's A. Okay? You got that one?
Yeah.
Okay.
Formula, right?
Just formulas. Yep.
Okay.
23. The circumference of a circle is 65 pi. In terms of pi, what is the area? Well, so, sorry, that should have said 65. Circumference is 65 pi.
Yeah.
What's the formula for circumference?
2 pi r.
Awesome. So if I clear the pi's on both sides, 65 divided by 2 is 32.5. Now I want the area in terms of pi. So 32.5 times 32.5 is 1,056.25 times pi.
3,300.
What? 32.5 times 32.5. Should be 1,000. I know, I keep hearing you guys say 3,000 something. Okay, did you multiply it by 3.14? That's okay. Look at the answer. it says in terms of pi, and it's 1056.25 pi. Okay?
So to be clear, circumference is pi r squared, and then area is 2 pi r.
No.
Did I get it reversed?
You got it reversed. And to help you, area is to the second power, right?
Oh.
It's two-dimensional. So it's the formula with the radius to the second power. That's how I remember it. So 24. All you're doing in 24 is you're finding the volume of one of these prisms, and there's 10 of them stacked up. Don't worry about the fact that they're tipped to one side. That does not make a difference. 5 times 6 is 30, times 2 is 60. There's 60 in one of them. They tell you there's 10. 60 times 10 is 600. Got that?
Got it.
Where's 6?
5 times 6 times 2.
Okay.
Because it's the volume of a rectangular prism.
Wait, why do you delay the test?
Don't ask questions. Just
I'm trying to make a video, but as I said, I delayed the test because I couldn't do study hall today. And then also, since we're not doing a study hall, I'm making the video, which right now you're hearing about, but as I'm telling you about it in the future, our future selves are actually watching it. Ooh. Say hi, future Noah.
Hi, future Noah.
There you go.
That's so cool.
It is. So, 25 and 26 are just volume of a triangular prism. Sorry, triangular pyramid. I said prism, I meant pyramid. Area of the base. To find the area of a triangle. 6 times 8 is?
42.
6 times 8 is?
48.
48.
Divided by 2 is 24. Multiply it by the height, which is 12. And then divide by 3. Okay? Okay, great. It's 96. 26. 8 times 12. Whatever you get, divided by 2. Times 16.
48.
Divided by 3.
768. 256.
There you go. 8 times 12. Divided by 2. That's area of the triangular base. Times the height, which was 16. Divided by 3. Because it has a pointy top. Anyone that has a pointy top is divided by 3.
Because that's the area of the triangle. Okay.
Yes.
Dividing by 3 is the same as multiplying by a third, right?
Yes. Dividing by 3 is the same as multiplying by a third. That's why the formula actually says multiply by a third. But if you start doing times 0.33, that's not the same as 0.333333333333. So you might get a rounding issue. That's why dividing by 3 is more accurate. Okay? 27 and 28 deal with BTUs. BTU stands for British Thermal Unit. It is a measurement of heat. Okay? These are actually density problems. We have had for homework density problems involving finding the density of like a metal, like copper or iron. We've had population density. So now we're going to use density in terms of heat. So the formula for density was density equals mass divided by volume. So even if you got concerned here that the amount of heat was your mass, I would hope that you get when they talk about 10 times 12 times 9, that's the volume, right?
Yeah.
So a human body that is performing light work generates about 650 BTUs of body heat per hour. You are giving off heat. When you are doing work, you are giving off more heat. Okay? So 3 people are working a total of 2 hours to paint a room. That's 6 hours of work, right? So 6 hours of work times 650 BTUs given off each hour is what number? 6 times 650 is what?
3,900.
And the volume of the room. It's a 10-foot by 12-foot room with probably about 9-foot ceilings. That's where the 9 feet is coming from. What's the volume of the room?
1080.
So 3,900 divided by 1080 is 3.6. So it's giving off 3.6 BTUs per square foot. Okay? We're going to use that same formula and deal with the human body. While it's sleeping, generates about 300 BTUs of heat per hour. So if 2 people are sleeping in the same room, like you have a friend sleeping over, it gets warmer in your room. There's 2 of you. So 2 people, 300 an hour. That means the 2 of you are giving off 600 BTUs of heat an hour. And you're sleeping, let's say, for 8 hours. I believe that's 4,800, correct? Mm-hmm. And your room is 12 feet by 12 feet with 9-foot ceilings. How much volume is your room?
1,296.
So when you divide, you should get 3.7. Do you understand those two?
How do we know it's density?
Because it is.